Given the following system, we want to find all of its transfer functions. So in the system, there are 3 inputs, R, W, and N, and there are 2 outputs, Y and U. Now essentially, when we find these transfer functions, in the end we're going to have 6, because we're going to be following this format down here, where we have the outputs, Y and U, and the inputs, R, W, and N, where essentially if we go with respect to Y, R is going to have its own transfer function, H11. Similarly, if we go with respect to U, N is going to have its transfer function with respect to U, which will be H23. So essentially what we'll do is we'll solve for 2 different equations for the outputs. We'll solve for Y, and then we'll solve for U. And then essentially what we'll do is we'll find the combination or the pattern of C and P, 2 other transfer functions, the control and the plant, and then we'll essentially figure out how those relate to the inputs with their respective output. So let's start working on that now. So with Y of S, we're going to focus on that output first. And with Y of S, we can see that is up here as an output. Now with every single transfer function, we're going to have, say, TF for the transfer function. That is going to be equal to the output divided by the input. So if we want to isolate the output, we can simply multiply the transfer function by the input. So now here, Y of S is going to be the output, where P of S is going to be the transfer function, and this branch here is going to be the input. So what we can start by doing is we can say Y is equal to P times the input, whatever this input is. So now this input, essentially this branch, is then connected to this piece here, where essentially we have W and U being added together. So let's essentially multiply by the input, which is going to be W plus U, because those are being added together. But now here, notice that U is actually another output, and we don't want to have multiple outputs in the same equation, otherwise things will get confusing, because we want to find our transfer functions with respect to the inputs, all with respect to the output that we're focusing on. But since we're focusing on the output Y, we don't want to have the output U also within our equation. So essentially what we have to do is we have to replace U, because notice U here is an output of this transfer function. So let's simply replace U with CS times the input to this transfer function, which is going to be this branch right here. So now with this branch, this is essentially, you can think of it as now the output of this right here, where we have R of S minus essentially this branch right here. So it's a lot of chaining back and forth. So it definitely takes a second to kind of put it in perspective, because it definitely is odd. So essentially we have U of S, and we're replacing that as the output with its transfer function times its input. So we have the transfer function already written down. Now with the input, that is going to be R minus whatever this branch is here, which with this branch we can see is the sum of Y and N. So we'll essentially have Y plus N. And this is actually the full equation for our output Y of S. So now what we can do is we can start to multiply things out to then solve for Y. So let's multiply stuff out. So we get P times W, and then we'll get plus P times C times R, and then we'll get minus P times C times N, and minus again P times C times Y. So now what we can do is we can add this term over to the left side here and then simply factor out Y of S. So let's do that now. So I'll have Y of S times 1 plus P times C, and then essentially be equal to P times W plus P times C times R minus P times C times N. And now the last step that we have to do is divide by this term to then isolate our output Y. So let's do that. So we'll have Y is equal to So we'll essentially have P divided by 1 plus P times C. This will be for the input of W. And then we'll have P times C divided by 1 plus P times C. And this will be for the input R. And then we'll have minus P times C, all divided by 1 plus P times C. And that'll be for the input N. So now we're essentially halfway there to getting all of our transfer functions. But now we have to first figure out which of these corresponds to H1, H2, and H3, or excuse me, H11, H12, and H13. So since we're dealing with the output y of s here, we're going to focus on these three transfer functions. Now this is simply just matrix multiplication, such that we have r corresponds to H11, w corresponds to H12, and n corresponds to H13. Now in the end, you could technically change the order of your r, w, n, and that would affect your order of your transfer functions, but given the order that we're in now, it'll essentially correspond to H11, H12, and H13, respectively, with R, W, and N. So we can start to label these below, just so we don't get them confused. So essentially W, that corresponded to H12, R corresponded to H11, and then N corresponded to H13. So now we are halfway there. So the next thing is we want to then solve for the output U. So we'll start out similarly, where we have U of S is equal to something. So now if we go back up here, sorry, it's going to be a lot of scrolling back and forth. Essentially, so U, that is the output of this transfer function times the input. So we'll essentially follow a similar format, where we have essentially C of S times whatever the input is. So essentially, go back up to this branch here, or here. Let me move this down. Let me copy this, just so we don't go up and down over and over again. There we go. That's better. Okay, so back to where we were. So we essentially had U of S as the output, and then we essentially had the transfer function C of S times the input, which is going to be this branch here. Now this branch, you can think of it as the output of this piece right here, which is essentially going to be R of S minus whatever this branch is. So essentially have R of S minus whatever this branch is. Now this branch here is N plus Y. So essentially go in another, so we'll have N plus Y. But now, remember from before, we don't want to have multiple outputs in the same equation. Because notice we have Y and we have U. Because we just want to isolate U so we can figure out what the inputs are with respect to U and find their corresponding transfer functions. So here, let's erase Y, because Y is the output of this controller, or excuse me, this plant here, the transfer function. So then that'll be multiplied by this input here, which is this branch. So essentially have P times whatever this branch is. But notice this branch is the output of this piece, which is going to be U plus W. So have U plus W. And now we actually have the equation for U. So now what we can do is we can start to multiply things out and then try to isolate U similarly to what we did with Y. So we'll get C times R minus C times N, and then we'll have minus C times P times W, and then minus again C times P times U. So then we can add this term to the other side, such that we get U all times 1 plus C times P, and that'll be equal to C times R minus C times N minus C times P, and then times W. Okay, so now we can then divide this term. So in the end, we get that the output U of S is equal to C divided by 1 plus C times P, and that is for the input R, and then minus C divided by 1 plus C times P, and that's for the input N. And then last but not least, we have C times P, all divided by 1 plus C times P, and that is for the input of W. So now what we can do is we can label these three with respect to their transfer function. So before we said that R here, so now we're on this line, essentially. We're on the second line corresponding to the output U. So R is going to correspond to H21, W is going to correspond to H22, and N is going to correspond to H23. So let's write that out now. So I'll go back down here. Sorry, there's lots of scrolling. So then for R, that is going to be H21 of S. N is going to be H23 of S. And then W is going to be H22 of S. So now what we can do is write the final matrix form with the 2 outputs, 3 inputs, and these 6 transfer functions. So this is going to be a decent size. So we have the outputs, Y of S and U of S, and then we essentially have all of the transfer functions. So I'm going to copy paste here just to hopefully save a little bit of time. So we have H11, that one here, and then we have H12, so that's going to go in the middle here in the first row, and then last but not least, for the first row, we got H13. So I'll go here, and then we'll take H21, H22, bring that in, and then H23. So then all we have to do is write the inputs, which is R of S, W of S, and N of S. So now we found all 6 transfer functions for the multiple input, multiple output, or MIMO system above,